stop here, but I make the problem is it's a little bit more than I think an hour to try to get through rickettsia. Let me just go through the introductory part. We won't go into the diseases. Let me get through some of the introductory part. And okay. All right, we're going to talk about a whole group of organisms here. The Rickettsia, Aurantia, Ehrlichia, Anaplasma, Coxiella, and the Bartonella. These are all different species. And the reason, or these are actually the different genera. The reason that these are handled as a group, it's basically for historical reasons, and also because of some of the diseases that they cause are pretty similar. But historically, these actually, with the exception of the Bartonella, all the rest of these were all at one time considered one group of organisms, all Rickettsia. And so these were called the rickettsial diseases. We know now that in fact these are completely different genera, and some of them are related, but even some of these are even not related. But they were considered all this one genera because basically the diseases that they caused were pretty similar. The reason Bartonella is thrown in this group is also because one of the diseases that this organism caused is very similar to the disease caused by one of the Rickettsia. So historically these were all at one time either considered to be the same species, or at least they cause similar type diseases. In addition, all of these diseases, with one exception, are transmitted by arthropod vectors. And so they were always considered to be related and similar, so that's why we treat them together, basically. And let me just give you just a brief history of some of these diseases. These diseases, the rickettsial diseases, have been documented, at least since the 16th century. Obviously, they existed prior to that, but the first earliest documentation of this as a unique disease goes back to the 16th century. And the disease was called epidemic typhus. And this disease, typhus, is actually associated with conditions of war and famine. That's typically when you see the disease, when there's famine and war. And although we've known, and this just gives you some statistics, in World War I and II, over 100,000 people were affected in those periods of the war with this epidemic typhus. Now, although we've known about this disease for, 500 years now, it's only actually in the 20th century that we began to realize what caused this disease and identify an organism that caused the disease. And in fact, the first rickettsia that was clearly identified as a unique organism was the causative agent of Rocky Mountain spotted fever, not the causative agent of typhus, but a different disease, Rocky Mountain spotted fever. And Ricketts is the guy that discovered this, and obviously that's why it's called the rickettsial diseases, named after him. And shortly after he identified the causative agent of that disease as being a unique organism, it was shown that, in fact, arthropods were the vectors for this disease. And then arthropod control measures were instituted. And once we started controlling the transmission of this disease by the arthropods, these diseases started dropping down in occurrence, okay? So we instituted these measures and these diseases disappeared, or not disappeared, but the number of these diseases at least dropped precipitously. But they're not gone. This is a quote by this guy, Hans Zinser. Hans Zinser made his career studying the causative agent of that epidemic typhus. And he points out that even though it's gone now, for all practical purposes, if we get into a situation with war and famine, these are likely to come back. And there are certainly areas in the world where this disease still does occur. So it's controlled, but it's not gone. Okay? All right, a little bit about the biology of these organisms. And we'll consider these as a group because the biology of these organisms is pretty similar. All right? So the Rickettsia, the Aurantia, Ehrlichia, Anaplasma, and Coxiella. These are all also obligate intracellular parasites. Okay? And again, just like the chlamydia, originally these things were thought to be viruses, but they're not. They're true bacteria. They contain DNA, RNA, ribosomes. They're bona fide bacteria. And we know now that all of these are completely unrelated genera, although their biology is similar and the diseases they cause are similar. They're really completely unrelated genera. They're gram-negative bacteria, but they don't stain particularly well with the gram stain. There's another stain, and you don't have to remember what the name of that stain is. It's called Gimza. But the gram stain doesn't work very well with these organisms, but they are gram-negative organisms. These are also energy parasites. But you notice I put energy parasites here in quotes because these are not strict or obligate energy parasites. If they have to, they can make their own ATP. But they do, in fact, when they infect their cells, parasitize the ATP. They may as well use the host ATP. But in the absence of host ATP, these organisms could make their own ATP, unlike the chlamydia, which can't. The chlamydia are obligate parasites. These are energy parasites, but they're not obligate energy parasites. They have a very effective transport system that they transport ATP into the cell. And there are reservoirs for all of these things, and we're going to talk a lot about what the reservoirs are. We're going to talk a lot about what the vectors are for each of these diseases. And the reservoirs can be animals, insects, and for one of the diseases, we're actually the reservoir for the disease. And again, all of these have arthropod vectors with the exception of the Coxiella. There's no vector for Coxiella. All right, so here's a list of the diseases that these cause and the agents. The disease Rocky Mountain spotted fever is caused by Rickettsia rickettsii. There's a tick vector involved in this, and the reservoir is actually the tick itself as well as rodents. So the tick in itself, and we'll talk about this, actually can act as the reservoir for the infection as well. Ehrlichiosis, there's 3 species that cause this, Ehrlichia chaffiensis, Erguini, and Anaplasma phagocytophilium. Again, all of them have tick vectors, and the reservoirs are in either mammals, small mammals, or in the deers. These differ sometimes in their geographic location where you find these. The disease rickettsial pox. And Jack, when we're finished, this thing I think needs to be replaced. The battery's going on this thing. Rickettsial pox is caused by Rickettsia acari. The vector is a mite, and the reservoir are the mite and the rodents. Scrub typhus we'll talk about. This is caused by Orientia tsutsugamushi. Okay, again, vectors and rodent and reservoirs. This is the most serious of the diseases, although it is not common because we're controlling this. This is the epidemic typhus caused by Rickettsia prowazekii. Now, in the epidemic form of this disease, when it does occur in times of war and famine, the vector is the louse, and we're the actual reservoir for this disease. But there is also a sporadic form of this disease, and there's actually the sporadic form of this disease is located in this part of the United States, in the southeastern part of the United States. But it's pretty rare. It's not very common. And in that case, the vector is the flea, and the reservoir is the flea or flying squirrels are acting as the reservoir for these diseases. There's another disease called murine typhus, and it's really a bad name. It's sometimes also called as endemic typhus. It's not an infection of mice. This is just called murine typhus or endemic typhus, caused by Rickettsia typhi. Flea is the vector, rodent is the thing. And in the last disease is Q fever, caused by Coxiella burnetii. This is the one that doesn't have a vector, but the reservoirs are sheep and cattle and goats and things like that. Okay, let's stop here and we'll pick up at this point tomorrow. We'll start with the Rickettsia.